Good evening all of you, and here is a problem which is basically I changed the problem of JEE Advanced 2007 to a new varieties. Okay, and let's see what we can do about it. So we have been given let 0 is less than a is less than b. It means a and b are positive numbers such that b is more than a. Define two sequence a and bn as follows: a naught is a, b naught is b, and we have a recurrence relation between the generation of n. So an plus 1 is gm of a and bn, and bn plus 1 is arithmetic mean of an and bn. Then we have this comprehension consisting of three questions. First, we have to find the uh, nature of this sequence an and bn, which is increasing decreasing. Second is about limit, and third is about the gap relation between the consecutive terms and the initial term b minus a. So before I go further, let's first understand the problem. So feel of the problem, let's generate. Let's say if I give two numbers, a is 1 and b equals 2. Clearly I can define what is a1. Why? Because a naught is a and b naught is b over here. So we have a naught as 1 and b naught as 2. So a1 according to this definition will be root 2, and similarly b1 is going to be 2 plus 1 by 2, which is 1.5. Now with a1 and b1 I can update my sequence, and that's the beauty of recursion. So I can find a2, which is square root of root 2 into 1.5, and we have b2, which is 1.5 plus root 2 by 2, and so on and so forth. So similarly I can keep on going, and I'll repeat the sequence again for a3 a4, and so finally I'll get some value of a10, we'll get some b10, and that is possibly we have to relate with option 3. Okay, now clearly the relation between 18 and b10 we need to relate with 1 and 2, which means the gap of 1 is not so obvious, because like the calculation will be very hectic, and this is not at all a good approach of doing the problem. Okay, so we have to relate these sequences in a very fundamental way. So let's start this relation. And the first way to relate this is clearly Ames inequality, because as you can see, this is geometric mean of two quantities and this is arithmetic mean of two quantities. So we know from Ames inequality, arithmetic mean is greater than or equal to geometric mean. So that shows b of n plus 1 is greater than or equal to a of n plus 1. Now here equality will not happen because the terms are not equal, right? So in general what I can tell is b naught will be greater than a naught as given in the problem. Similarly b1 will be greater than a1, b2 will be greater than a2, and so on and so forth. So since here a and b, the starting point was not equal, hence a1 and b1 will also not be equal. So we'll have a strict inequality. So from here is direct consequences tells is bn is greater than an. So that was fairly simple, and the first option is correct. Now next option, so that clearly discards option number B. Okay, now coming to option C and D, what we have to check is whether the sequence AN is an increasing sequence or decreasing, and so is BN. So how to comment about this? Now one way to feel this question is, okay, let's see if we have a number A naught and B naught. So where will be exactly A1? A1 is arithmetic mean, is geometric mean, so it will be somewhere here. Okay, and arithmetic mean b1 is going to be here. So we know since arithmetic mean will beat geometric mean, so b1 and a1 location will be this. If again I take these two as the inputs and I calculate b2 and a2, so we'll have b2 over here and a2 over here. So with feel you are getting these distances keeps on reducing, right? These distances will keep on reducing, and definitely the feel is telling like those limit will try to merge to the same values. Okay, but still let's do it rigorously. So let's start this. So यहाँ पे we already know since we have bn plus 1, it's arithmetic mean between an and bn. In fact, to start, a1 will be definitely greater than a naught, a2 will be definitely greater than a1, a3 will be definitely greater than a2, and so on and so forth. So from here what we are getting, because of the arithmetic mean placement is in between, so from here the conclusion that I got is n is a monotonically increasing sequence. Monotonically increasing sequence means n is greater than an minus 1 and so on and so forth. So if I'll see a naught value, it will be lesser than a1 value, is lesser than a2 value, a3 value, and so on and so forth. Right, so that marks option C as correct. What about Bn? Now Bn is, we can clearly see one of the point which is obvious from here, since we know the Bn value is greater than An value by arithmetic geometric mean property. So if I'll consider B of n plus 1, which is half of An plus Bn, and we know since Bn value is more than An, so this will be less than equal to half times Bn plus Bn, which makes this less than equals Bn, right? And this follows directly from MG inequality. So now Bn plus 1 is less than equal to Bn, which shows if I start with B0, so that will be greater than B1, and that's indeed will be greater than B2 and B3 and so forth. So we got B as a decreasing sequence, right? So the sequence B is monotonically decreasing sequence over here. So we shows the lower index will win, so hence option D is correct. Let's come to the GM sequence of A n plus 1, and here we go with that. Now we can check A n plus 1 is still root A n n times Bn, and since we know Bn is more than An, right, so this quantity will definitely be more than root over n into n, or equal to, in case the initial numbers are equal, but here a strict inequality will happen because I have not started with the equality. So that is indeed greater than n. So that shows a n plus 1 will be more than n, which means if I put the value of, let's say, n0, so a1 is more than a0, a2 is going to beat a1, a3 is going to beat a2, and so on and so forth. So we have a sequence n more than an minus 1, more than an minus 2, and so on. So clearly A, which is this GP sequence an, becomes an increasing sequence. So that shows option C is also correct. So the final answer for the first question was A, C, D. Let's move to the second part of the problem, and that's quite interesting because this part shows, like in the limiting case, when you start this operation, let's say I gave you the example of 2 and 1, and you keep on repeating it infinitely long, then in the dash situation, the sequence an and bn will try to merge to some particular value because it will be convergence sequence, as you can see from the structure of the recursion, and moreover it can be proved very easily. So what is that convergence limit? Are they equal, are they less, or are they more? Now again, with the field, it's quite obvious that a convergence should be equal, because if I start with any two number, let's say not b naught, with b naught strictly get an a1, their geometric mean is over here, which I call an, and arithmetic mean is, let's say, bn. So with b naught we have a1 b1. Again for these two guys we'll have again b2 and a2. Again for those two guys we'll have a3 and b3. So it's trying to go towards this limit. So both of these guys, L1 and L2, is trying to approach towards a fixed value. So in that sense I can tell option A is true. But that is just out of field. Let's do it mathematically. And the way we are going to do mathematically is, first we'll target option 3, and using option 3 I'll try to mathematically prove option 2. So let's see, option 3 is telling it's a connection between b and a and n. So clearly you can see in these options, here we have n plus 1. So basically it's trying to connect bn minus an is less than equals 1 by 2 ka power n b minus a, because 10 is not a special. So at least we'll try to prove or disprove it. So let's start the game, right? So if I consider bn minus an, which is again bn is your arithmetic mean and an is geometric mean. So bn will be ahead of n. We'll have the next guy, which is again b n plus 1 and a n plus 1, as these two numbers somewhere between this, right? So we are interested in this gap. So we are interested in the gap between a and b, and clearly that gap will be like more than the gap between an plus 1 and bn plus 1, so there is no doubt in that. But what's more interesting is, since an sequence itself is a, here we have seen an sequence itself is an increasing sequence, so in that sense, instead of an, what if I replace and compare this with b an minus 1, right? So we'll have an minus 1 sum over here, bn minus 1 is here, and you can clearly see the gap between an minus bn is more than this gap. Okay, moreover, since an is more than an minus 1, so this quantity is smaller, so this graph increases. So bn minus an minus 1, the RHS is definitely going to be greater than bn minus a, right? Now by the definition of bn, we can directly replace n with n minus 1, so we'll have half times of bn is half times of n minus 1 plus bn minus 1, n minus 1 plus bn minus 1 minus n minus 1, and that will give you half times of an minus 1 plus half b n minus 1 minus an minus 1, which evaluates to half of bn minus 1 minus an minus 1. Now again, you can use the same logic over here, because bn minus 1 and an minus 1, again it will be lesser than equal to half times, and bn minus 1 gap versus an minus 1 gap, right? So I can write this, it will be bn minus 1 minus, it will definitely be greater than the gap of an minus 2. And now again, with that recursion, bn minus 1 can be written as an minus 2 plus bn minus 2 over 2 minus an minus 2, which gives you 1 by 4 times bn minus 2 minus an minus 2. And it's no wonder, you can keep on doing this, and we'll have 1 by 2 to the power k bn minus k minus an minus k over here, right? This is true for any k, as long as k is lying between 1 to or 0 to n, 0 to n, right? So one day this will descend down, and for value of k, when if I will take k equals n, so that they will go to the base case 1 by 2 to the power n, will have b0 minus a0, and that's fantastic, because this gives us bn minus an, this sequence is less than equal to 1 by 2n 2 to the power n b0 minus a0. Okay, so with this we have already proved the first option, and clearly second option is wrong. The third option is also wrong, because we can see 8 and 8 will cancel, and that will mean b10 and b12 is equal. That's clearly wrong, because b is not a constant sequence, as we have seen, right? So next is how using this we are able to conclude option 2, like question 2, or is it true that b10 minus a11? So that's fine, because we have b10, we have a10, and a11 is going to be somewhere between a10 and b10. So the gap between a10 minus b10 and the gap between b10 and a11 is definitely lesser gap, right? So this quantity will definitely be lesser than this quantity b10 minus a10. Now if this value is more than b10 minus a10, definitely it's more than its a value which is less than that. So in that sense, option C is also correct. Okay, and now we are ready to prove the question for part 2, because here if I'll take limit n tends to infinity bn minus a in this sequence, that will be lesser than n tends to infinity b0 minus a0 by 2 ka power n. And see, we started with the finite value of b0 and a0, so this is some finite divided by 2 to the power infinity, and that's going to be 0. So now we know, since this sequence is continuously changing and bn and n is continuous sequence, hence we can tell the difference of limit is limit of difference. So limit n tends to infinity bn minus limit n tends to infinity an is going to be lesser than equal to 0. But We know from AMG inequality, Bn sequence is always more than An sequence for any particular n because of AMG inequality. So that will show Bn is always more than equal to n. So hence limit n tends to infinity, Bn has to be more than equal to limit n tends to infinity. Right, this is happening. This is not true in general, because if a function f is greater than g, we can't tell limit x tends to a f is definitely greater than limit x tends to a g. That's clearly wrong, because they might merge to the same limit as well, right? But here, like this, since the sequence is continuous, so I can tell this sequence bn an is trying to go, so the gap between a and bn is lesser than any ipsa, whatever ipsa you select, 10 to the power minus 100 or something, 1000, and keep on. So you can make this graph arbitrarily small as possible, and moreover bn is more than an. So from Sandwich theorem, I can tell here we are getting this an minus bn value is almost when n is too large is less than 0, and we know it will definitely be more than 0. So from Sandwich theorem, when n is too large, this value has to be 0. It means an and bn sequence will almost merge to the same limit L. Right? So this was a beautiful question of its kind. Of course, JEE Advanced can give you a test of AMGM HM also, and you can do similarly. Now the best way to do this kind of problem is to either take a smaller number. Of course, you could have taken A and B, but in this case, that's why I defended you not to take. Okay, so you are not allowed to take A and B as equal. Otherwise, if you take A and B, of course, for second part option, it will be obvious. Moreover, you could play with n. Like even if it is A and B is unknown, you can just calculate A1, B1, A2, B2 and go with option scanning technique. Please do like and subscribe my channel for quality content for free. Thank you. Have a good day.